Hi, Evan.
Hi, Evan.
If you watch, like and subscribe. This is where we left off on Friday, right? And what we said was setting it up was what's difficult, right? Trying to figure out what that looks like visually, it's tough. But once you get to this point, that's taking a derivative of that. It's a piece of cake, right? No problem. Oh. So this is what I did, right? To set up. I just wanted to have an idea of what I'm looking at. So all I did is I said, okay, well, I got to be closest to the origin. My cosine curve starts at 1. You know it does that and does that. And so I can at least visualize it. And so we all agree that the answer to this problem has to be at the absolute worst case scenario, what? 1, right? Because this is 1 away, right? And what's pi? 3.14. What's 3.14 divided by 2? What's 3.14 divided by 2? Well, yes.
Oh.
Yes, but as a decimal, okay, hang on. We're okay, so guys, in calculus, what is pi equal to? 3.14. Okay, so if I take 3.14 and I divide it by 2, that's 1.57, right? So we know that that can't be the closest point. So this is our best case scenario. Maybe there's another point that is what? Closer. So what did I say? I found the distance, right, using the distance formula. Or do you guys agree I could use the Pythagorean theorem, right? So if I put a point here, this would be x. This would be cosine of x. This would be my distance, and so I could use the Pythagorean theorem. And I said, okay, well, I'm going to do this on a domain from 0 to 1, right? I'm going to do this on a domain from 0 to 1. And of course, I want to minimize that. Guys, with a calculator, right? So again, right now, I'm not worried about if you can take this derivative, right? What I would hope, Brandon, that you guys do is realize that this is a chain rule problem, right? You have an inside, you have an outside. You would take the derivative of this and you would multiply it by a half of this to the negative a half, right? And that's the way you would do it by hand, right? Were this a calculator problem, there's a couple of things you could do. Well, this is the graph that I want to know the minimum of, right? Well, can I just graph this and find the lowest point? On what interval? 0 to 1, right? So were this a graphing calculator question, we would go square root, oops, Okay, that's my graph from 0 to 1, correct? Is it? Yeah. My question is there a what? Is there a minimum? Oops. It brought me all the way back over here. Why do you think it did that? Because what do you think all these values are in here? All the same, right? Remember, a graph has a minimum or maximum if there is no point higher than all other points or no point lower than any other point, right? So is this a minimum? Yeah. So what's the minimum? 1. Yeah. Yeah. So actually, this point right here is the closest, right? And every other point is further away. Lexi, again, if you were to do this by hand, right, you would take your derivative, find your critical values, right? And then look at your endpoints as well. Cool? So what I did for this one, the manager of an 80 apartment complex is trying to decide on rent. Experiences showed him that at $200, he'll rent out the whole place. But if he increases the rent by 20 bucks, he's going to lose a tenant. Right? So he makes it 220 and now he only has one unrented apartment, right? So what would be his income? It would be 79 times 220, right? If he raises it to 240, two apartments are going to go unrented. So what's his income? 240 times 78, right? So I came up with the following formula, right? And again, it's problem solving, right? It's looking at this, seeing if you can come up with a pattern, right? So what happened here? Well, U is going to represent the number of apartments that are unrented. How was I calculating revenue? The rent times the number that are rented, right? So what did I do? I said we're going to start at 200 and we're going to increase the rent by $20 for every unrented apartment. Increase by 20 for every unrented apartment. And then we're going to multiply it by 80 minus U, because if U represents the number of unrented apartments, then 80 minus U represents the number of rented apartments. And there's an equation. Guys, not saying that's the only way to do it. There are probably others. This is the way I chose to do it. So I have 200 plus 20U. Times 80 minus X or U. And what makes sense here, guys, for X's? What does X represent? Number of units that are unrented. So what makes sense? 0 to 80. Now I got to do a what? Zoom fit, right? Once I get my domain. All right. There's my graph, right? What's the apartment manager trying to do? Maximize his income, right? So maximum is 35 unrented apartments, right? So if I have 35 unrented apartments, again, I hate when the calculator does this, but what does this mean, e to the 4? It means take this decimal spot and move it to the right 4 places. I don't know why it does this. Sometimes it does, sometimes it doesn't. It's just weird. We could also go to our table. And this is the income, right? This is the amount of revenue. And so we're seeing revenue continue to rise until we said how many unrented? 35, right? And so there we see that maximum point at $40,500, right? Again, were this one that you had to do by hand, what would you do? I would FOIL this, right? take our derivative, set our derivative equal to 0, and find our critical value, right? And that critical value would have been 35. Cool? All right. So, don't copy down, yeah? I mean, listen before you write. Listen before you write. So here's what we got. We got a guy who's coming in with 12 meters of framing to create an enclosure for this glass, right? He wants to maximize the amount of light, which means he wants the most glass possible, right? He has a semicircle on top. Semi means what? Half, okay, so it's exactly half. So what do we know about the perimeter or the circumference? Circumference is equal to 2 pi r, right? Or pi times diameter. So I said, okay, great, let's call this the radius of the circle, okay? So that means that the amount of framing material that we need would be half of the circumference, right? So that's going to be what? This distance, right? Everybody got that? Then the area of the circle is pi r squared, right? But we don't have a whole circle, we have half of a circle, so pi r squared divided by 2. Okay, so this is the circumference involving the blue. This is the area involving the semicircle. Cool? Awesome. Then I called this L. But what did I call this? 2R. Why do they call it 2R? Because the less variables I have, the better, right? Could I have called it W? Sure, but then I got to go back and substitute at some point anyways, okay? So the area of this region is L times 2R or 2LR. The perimeter of this region is L plus 2R, 2L plus 2R. So what does my framing material require? It requires this plus, I wrote the wrong thing. 2L plus 2R plus pi over R. Equals 12, right? So Lexi, it's what? It's this, 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 and then that piece, right? So it's these things. And then the total area of the glass is the pi r squared divided by 2 plus the 2LR. Now this isn't too bad, guys, because I have how many variables? 2. And that's okay, because what am I trying to optimize? I want something that's going to bring in the most amount of light, so I want to maximize the area of the glass, right? So what does that mean I'm going to do? I'm going to go to this one, solve for one of the variables, take that, because that's my constraint, right? The amount of framing material. Take that and plug it into that, and then find the derivative of that. Cool? Now, were this a graphing calculator section, right? What might you do? How might you go about doing this? You want to put both in? Well, what do I? Okay, so you're thinking define these? Yeah, we probably could. I would probably say that the best thing would be to solve for what over here is pretty easy to solve for. L. If I solve for L, take that. Now, if I have an L equals something, I can plug it into here pretty quickly, and then graph this and find the greatest area. Right? That would probably be the quickest way to do it. All right? Cool. This is how that right there. Again, there's a lot going on there, but it's a tough problem. Oh, do you want to write? I told you guys not to. Austin's writing. You good? I didn't write much for this because there's actually not much to do. Here's some equation, right? Guys, ready? This represents profits, where X represents the number of widgets that you offer. Okay? This is the profit function based on the number of widgets that you offer. So what does everybody want to do? Maximize the profit, right? Which means I want the point on that curve where I have the greatest slope. So what has the greatest slope on this curve? Well, I don't know. It looks something like this, right? I'm just throwing something up there. So what has the greatest slope? Well, I don't know. Maybe it's right here. Or no. Maybe it's right here. Oh, no. Maybe it's right here. What am I doing right there? I'm analyzing what to the what? What am I drawing on there? I'm analyzing tangents to the curve and looking for the one that is what? Greatest, steepest, correct? Right? So which f prime is greatest? So what do I want to do? I want to maximize or optimize f prime. Okay, so let's do that. There's my derivative. What do I want to know about the derivative? I want to know where on that curve is the greatest. I want to optimize that. So how do I optimize something? I take the derivative of it. So what am I going to do? I'm going to take the second derivative. And I want to find the critical values of that. Okay. Now, should I do a little bit of an analysis for this? Sure. So here's my number line. There's no constraint on the domain here, right, guys? So it could be anything. So were I to plug in, again, what am I plugging into? Plugging into the second derivative, right? If I was to plug in -5, this would be a positive value. If I plugged in 0, this would be a negative value. So if I went from increasing to decreasing, that means -1 had to have been a max. Ready? Quick question. Does that mean that the biggest slope is -1? No, that means that the biggest slope occurs at -1. If I want to know what the biggest slope is, what am I going to do? The largest slope occurs at x equals -1. Okay, so now I want to know what is the largest slope? Plug it back into what? The original or the derivative now? Into the derivative, because I want to know what the biggest tangent is. Oh, geez, hang on. I plugged it in the wrong spot. Got to plug in the derivative. Careful right here, guys, right? That's -2 plus 2. Is it +1? It should be -1, right? Okay. So this is the largest slope. Kind of weird, right? Largest slope is actually negative. That means your original graph was always you guys are amazing. It means your original graph was always decreasing. Yeah, absolutely. Have I answered the question? It says find the equation to the graph having the maximum slope. So when you see find the equation, you know that you're going to do one of these. I know the largest slope is -1. I know where it happens. It happens at -1. So the two negatives make the positive, right? I still need to figure out the where for the position on the graph, right? So how do I figure that out? Take -1 and plug it into the original. And on the original, if you plug in -1, you get 2. And there's your solution. Now, Brandon says that he thinks this graph is always going to be decreasing. Let's look at what that original graph actually looked like. Two-thirds. Minus 2x. Minus x squared. Minus a third of x cubed. And there it is, Brandon. And if you were to zoom out of this thing, you would see that this graph is always doing this, always decreasing, right? And we said that the steepest, greatest tangent was this. Right? And you can see it's tangent because the graph goes like this, right? But that's actually that's the greatest. So a -1 is the greatest one. So I know that that's kind of counterintuitive, but if you think about it, anywhere along here, it's going to be what? It's going to be more vertical, meaning lesser number, right? In terms of steepness. It's kind of cool, right? So if you think about it, guys, if you can take situations, guys, there are mathematicians that do this all the time. What are they doing? They're analyzing stock markets, right? What are they trying to do with stock markets? They're trying to find regressions. What are they trying to find regressions of? How data fits to a particular curve. Because if you can get the data of a market into a pretty good regression, remember regressions with R values, Brandon, right? A perfect regression has an R value of 1, right? Remember that back in Algebra 2? So if you can get something that's really, really good in terms of accuracy, and now you can analyze its change and find points on that curve of greatest and least, you can predict now, can't you? Right? You can start to predict what might happen. So there are mathematicians doing this all the time with stocks, bonds, trades, equities, cash, currency exchanges. It's huge. Bitcoin right now, guys, right? Trying to find some trends in the data and get it to fit mathematical curves and predict. So exciting stuff, isn't it? My goodness.